Let's walk through a basic Firebase cloud messaging implementation on glitch.com. We've prepared this glitch as a standalone example to make FCM as easy to understand as possible. Feel free to remix this glitch or copy-paste code for your own implementations. FCM is one of those systems where copying and pasting code is a best practice. It's mostly boilerplate, and that's what open source code is all about. So you can sit back and relax, because this is just another walkthrough. We'll go through the FCM implementation in detail later on. Our glitch is named find_ping, so we'll navigate to find-ping.glitch.me. We'll open DevTools and find the client.js source file. We'll set breakpoints on lines 35, 54, 56, 59, and 70. Let's reload the page to see line 35, where we're instantiating the messaging client library. Now let's sign in with Google to get an authenticated user. Once we've signed in, we'll click the Request Permission button. This triggers our breakpoint on line 54. A simple call to messaging.requestPermission causes the browser to request our permission. We allow permission, which calls the callback on line 56. Line 56 calls messaging.getToken to generate a unique token for the browser session. We receive the token on line 59 and send the token to the real-time database. Let's navigate to our real-time database console to see the data. It's all under authenticated/notification-users. You can see the existing user objects with their tokens. Now back to the glitch web page to define a message, any message. We'll click on the send button to trigger line 70. Line 70 sends a post request to our server. Notice the token and message query parameters. We'll let that play through and go check out the server code. Server.js contains our post handler. It pulls the token and message attributes from request.query and sends the message. Admin.messaging gets the server library, and .send does the sending. The message body needs token and data attributes, which will go straight to our client. Let's return to the client and trigger another message. Each message triggers the onMessage callback on line 41 of client.js. The onMessage callback gets triggered whenever the app is active in the browser. But what if the app is closed or running in the background? Can we still receive notifications? Of course we can. We can use a service worker to execute code while our app is in the background. In the DevTools console, there's an application tab that lets us view our service worker code. We'll select the service workers page and click through to our service worker. Line 14 registers our set background message handler callback. It's like the earlier onMessage callback, but it only fires when the app is in the background. So let's trigger a message while the app is in the background. We'll do this by going to the Network tab in DevTools and finding our last send message post. We'll right-click on the request and copy the request as curl. Now we'll hop into our bash command line and fire off the curl command to recreate the post. This example is using the Windows 10 Linux subsystem version of bash. If you try this copy as curl trick on macOS, you don't need to use the Linux subsystem. macOS has a bash terminal by default, so your life is that much easier. We've left the glitch app in front of our browser, so the regular alert triggers. Let's try that again while on a different tab. We'll send the curl command again. And check that out. It's a system-level notification from our browser. This example sends a single message to a single user. Real-life production apps will need a lot more application-specific logic. You can use FCM to subscribe users to topic messaging lists. And you can use Node.js to send mass messages to those topic lists. Also, you'll need to manage user tokens in a more sophisticated way, because the system only saves one token per user. In real life, users log in with lots of different browsers, each of which needs its own token. And another quick note, Firebase Cloud Messaging uses the browser's Push API. The Push API is currently only supported by Chrome and Firefox, so don't build mission-critical functionality with these kinds of messages. Firebase Cloud Messages should be viewed as a progressive enhancement, meaning that users with better browsers get the enhanced experience. But we need to develop our app to still work well for less privileged users. That was all very fast, and bouncing between client and server code is confusing. So hang in there. We'll be building a production-grade messaging framework, and you'll be able to use your framework in any app with just a bit of copy-paste.